Okay, more indefinite integrals. They've made the powers a little hairier here, but we have a system, so we should be all right. They start off with x to the 10th. So we have x to the 10. You notice these always contain a dx, or they always should, and I always kind of ignore it when I'm doing the antiderivative. This has to be there at the tail end of the derivative, we know that, but it doesn't really affect any of the calculation we do here. So if someone writes an integral which does not contain that dx, that's a problem and it means they've screwed up. But the presence of this dx, while it is required, doesn't really change anything about how we think about the antiderivative. It's just a feature that has to be there. So if we have x to the 10th, you remember our rule was the opposite of the power rule. So where the power rule says multiply by the power, then cut the power by 1, for us, the reverse of that is increase the power by 1. X to the 10 becomes x to the 11. Then divide by the new power. You can just put this over 11. You can write 1/11th. I do a mixture of the two. And, as usual, don't forget your constant. If you have 20x to the 4th, you know the drill. Up by 1, then divide by it. So the power of x to the 4th becomes x to the 5th. Then divide by the new power. And 20 divided by 5 is simply 4, so 4x to the 5th plus c. There we go. P cubed dp is our original. Can you do it in your head? Power up by 1 is going to be p to the 4th, and then divide by that, so it's going to be 1/4 p to the 4th. Power goes up by 1. And then dividing by 4 means you can either write that plus c, or if you'd prefer, you can write this plus c. It's all good.